Hello, my name is Jamielee Hyatt, and today I will discuss reducing capture myopathy in cranes. Capture myopathy occurs from the stress, fear, and physical exertion during capture evasion in wild animals. There is no standard method of capture to prevent capture myopathy, but we can reduce its rate and associated mortality. Capture methods for cranes, such as helicopter, cannon nets, Australian noose, claptrap, and chemical immobilization, vary in time, effectiveness, and mortality. Today, I review the techniques used to capture cranes and suggest the best method for reducing capture myopathy. Helicopters. Inside a helicopter, the pilot and two observers scan the landscape until they detect cranes. They follow the same crane 30 meters above and 150 meters behind until it separates from the group. Then the helicopter hovers above the crane for 1/2 to 2 minutes to encourage hiding. The helicopter moves out of sight and the ground team is deployed. The ground team rushes in and grasps the bird by hand or uses hoop net. They found swift and high reliability with grounding flighted birds, yet handling time exceeded 1 hour, and 1 out of 6 cranes developed capture myopathic symptoms and died immediately. Cannon nets. Researchers hide, attract cranes, deploy the net, then bind cranes for processing. Selectivity is one of the benefits to this method, although contingent on the researcher's skill. As employed by Veltheim et al., they were not very effective since they only captured 3 cranes after 19 days and capture myopathy was observed in 1 out of the 3 captures. Researchers stayed within a camouflaged hide 50 meters away from noose traps and used bait with a decoy and called playback to attract birds. The noose consisted of an elastic cord attached to line ends, which were made of Army Hoochie nylon cord arranged in a zigzag pattern. After capture, they wrapped and hooded the bird and immediately released if stress was evident. They left the site and returned 24 hours later. The pros include low handling time, low time required for setup, and they did not observe capture myopathy. It was not very effective as only 8 cranes were captured after 23 days. The claptrap involves pre-baiting with corn and waiting until cranes are observed feeding within a mock trap before setting up a real one. The trap is dyed to blend in with surroundings. From inside a blind, an observer triggers the trap and other researchers emerge to collect the crane. The appropriate position is to wait for the crane to have its head down while feeding. Parker et al. Did not observe capture myopathy. This method is highly effective. In 17 capture events, they caught 28 cranes. They captured the same crane more than once, and only minor injuries were sustained in 3 cranes. Each trap cost under $40 to produce. It did not take long to remove birds from the traps. Some of the cons of this method include interference from livestock, time-consuming to set up, and this method requires habituation and proper positioning of the bird to trigger. Chemical immobilization. A social group is pre-baited with a standard amount of corn to condition the group to eat the corn regularly. Once the group arrives at the bait site and remains for 1 hour for 3 consecutive days, researchers apply alpha-chlorelose to the corn bait prior to sunrise. Once the cranes fall asleep, researchers wrap and hood cranes to prevent movement during transport. After obtaining data, they remove hoods and wraps and begin physical therapy for circulation by moving legs and wings. The cranes are placed inside a holding pen with researchers monitoring every 3 to 4 hours during recovery until migration. Crane parents will sometimes stop eating to allow their chicks to consume more food, and it's not possible to control individual rates of ingestion, so there is a gradient of sedation outcomes. Hayes et al. And later Hardup et al. Achieved low capture myopathy at 2.3% and were effective at capturing the entire social group. Some of the drawbacks include the long time cranes spent in confinement, up to 35 hours, the additional permits required, and the additional time and expense. An unacceptable amount of capture myopathy was reported from cannon nets and helicopters, while chemical immobilization and Australian noose traps were very low. Researchers with clap traps did not report any myopathy, yet they also did not observe the cranes long enough to check. My recommendation for reducing crane capture myopathy is to consider site and species-specific trapping methods, avoid cannon nets and helicopters, and perform more research and monitoring on capture myopathy for the noose and clap traps. For the lack of capture myopathy observed, low handling time, selective capture, and low cost, clap traps seem best. Thank you to the researchers who provided the basis for this project. And a special thanks to Jeremiah Thompson for beautifully illustrating the cannon net and chemical immobilization methods. Thank you for watching, and if you have any questions, please comment below.